In Python, functions are not merely sequences of commands, but are objects in their own right. This unique characteristic allows us to treat functions like any other object. For example, they can be assigned to variables, passed as arguments, and even returned from other functions. This leads us to a special class of functions known as higher order functions, which are central to a functional programming style within Python. Let's talk through some of the characteristics of higher order functions. Firstly, Python treats functions as objects, making them first class citizens in the language. This means that a function can be assigned to a variable, passed as an argument, or returned from another function. Assigning a function to a variable doesn't invoke the function. Instead, it creates a reference to the function. For instance, consider the third instruction in this code snippet, process equals process underscore log underscore entry. Here, process becomes another name for the process underscore log underscore entry function. Python allows passing functions as arguments to other functions, enhancing the flexibility and reusability of code. This is particularly useful in scenarios where the behavior of a function needs to be dynamically modified or decided upon. Take a look at this example, for instance. We have a function called detect underscore anomaly that accepts one argument called value. The analyze underscore prices function accepts two arguments, a price list, as well as a function here referred to as anomaly detector. And when we're looping through the prices in the code, you'll see that on line 3 of the analyze underscore prices function, there's a conditional saying if anomaly underscore detector with an input argument of price, where anomaly detector is actually the function that has been passed to the analyze prices function. So the last line in the code you see on your screen right now showcases this, where we've passed a list of numbers, including 90, 102, 110, and 95. And then the second argument is detect underscore anomaly, which is the name of the function we wrote at the beginning of this snippet. Python supports returning functions from other functions, and this can be used to create function factories, where a function configures and returns another function tailored to a specific need. Functions can be stored in various data structures like lists, dictionaries, etc., allowing for dynamic and flexible program structures. Then we have decorators in Python, and these are a direct application of higher order functions. They allow the modification of a function's behavior without altering its code. And by wrapping a function within another, decorators provide a powerful tool for code extension and management. Let's take a look at this snippet, for instance. We have the decorator function defined at the beginning of the snippet, log processor decorator, which consumes a function. Internally, it has a wrapper function that does processing based on those inputs, and then the wrapper is returned to the calling party. This function's name is then used as the decorator name. So you can see on the last 4 lines, the process log entry function has been decorated with the log processor decorator. Python has some built-in higher order functions, and these are called map, filter, and reduce. Map applies a function to all items in an input list or collection, for example, using map to process multiple log entries. Filter filters items out of a sequence, for instance, using filter to find genomic patterns. Reduce reduces a sequence of elements to a single value by cumulatively applying a function. For example, you can use reduce to aggregate anomaly detections, as in our stock price anomaly detection examples that we've gone through in the hands-on so far. Before we do a hands-on coding session for higher order functions, we need to discuss a few more things. So let's head over to the next section on generators and see what those are. See you there.